Welcome to Chapter 4 of Class 7 Science, the world of metals and non-metals. In this fascinating chapter, we'll join Yashwant and Ananda as they visit local ironsmiths in their Rajasthan village to learn about metals and their properties. We'll explore the unique characteristics that distinguish metals from non-metals, conduct experiments to test material properties, and discover how these materials behave in different conditions. From the malleability that allows metals to be shaped into useful objects to the conductivity that makes them essential for modern technology, we'll uncover the science behind the materials we use every day. Let's begin our exploration with Activity 4.1, where we'll investigate different materials to understand their properties. We'll examine copper pieces, aluminium pieces, iron nails, coal, sulfur, and wood blocks to observe their appearance, hardness, and what happens when we beat them with a hammer. You'll discover that metals like copper, aluminium, and iron are lustrous, hard, and become flattened when beaten. This property is called malleability. Meanwhile, non-metals like coal and sulfur are non-lustrous, brittle, and break into pieces. Wood shows different behavior altogether. Remember, not all metals are the same. Sodium and potassium are so soft they can be cut with a knife, and mercury is liquid at room temperature. Now let's explore two more important metal properties, ductility and sonority. Ductility is the property that allows metals to be drawn into wires, which we see in electrical wiring, ornaments, and musical instruments. Gold is incredibly ductile. Just 1 gram can be drawn into a 2-kilometer-long wire. Steel wire ropes, made from an alloy of iron and carbon, demonstrate both strength and flexibility in suspension bridges and cranes. Sonority is the property that gives metals their characteristic ringing sound, which we hear in school bells, gun grooves, and temple bells. In Activity 4.2, we'll drop different objects and observe that metals produce ringing sounds while non-metals produce dull sounds. Let's investigate two crucial properties, heat and electricity conduction. In Activity 4.3, we'll test heat conduction using metal and wooden spoons in hot water. You'll discover that metals are good conductors of heat, which explains why we use them for cooking vessels, while wood is a poor conductor, which is why we use it for handles. In Activity 4.4, we'll test electrical conduction using a simple circuit tester. Metals like aluminium, iron, and copper allow electricity to flow and make the bulb glow, making them good conductors. Non-metals like sulfur, coal, and wood prevent electricity flow, making them poor conductors. This understanding helps explain safety features like plastic handles on tools and rubber gloves for electricians. Now let's explore how metals interact with their environment through Activity 4.5 on rusting. We'll set up 3 bottles with iron nails under different conditions: dry air, water without air, and both air and water. After observing for 8 to 10 days, we'll discover that rust only forms when both air and water are present. This brown deposit is iron oxide, and the process is called corrosion. Rusting causes significant economic damage, but we can prevent it through painting, oiling, greasing, or galvanization. Interestingly, the ancient iron pillar of Delhi, made over 1600 years ago, shows barely any rust despite centuries of exposure, demonstrating advanced metallurgical skills in ancient India. Let's compare how metals and non-metals behave differently with air and water. In Activity 4.6, we'll burn magnesium ribbon, which produces a dazzling white flame and forms magnesium oxide. When tested, this oxide shows basic properties, turning red litmus blue. Metals generally form basic oxides. Sodium is so reactive it must be stored in kerosene to prevent contact with air and water. In activity 4.7, we'll burn sulfur, which produces sulfur dioxide gas. When dissolved in water, it forms sulfurous acid, showing acidic properties. Non-metals generally form acidic oxides. The key differences are clear. Metals are lustrous, hard, malleable, ductile, sonorous, good conductors, and form basic oxides, while non-metals have opposite properties. While metals get much attention for their obvious properties, non-metals are equally essential for life and technology. Oxygen, a non-metal, is essential for respiration. Without it, we couldn't survive. Carbon is the building block of all life forms, present in proteins, fats, and carbohydrates. Nitrogen is crucial for plant growth and fertilizer production. Chlorine purifies our water, and iodine serves as an antiseptic. In modern technology, metals and their alloys play vital roles in atomic energy, aerospace, and various industries. Recycling metals like iron and aluminium contributes to sustainability. India has rich metalworking traditions like Dokra, Bidriware, Pembarthi, and Kamrupi metal arts that showcase our cultural heritage. Congratulations on completing Chapter 4. You've learned that metals are generally lustrous, hard, malleable, ductile, sonorous, and good conductors of heat and electricity. They form basic oxides when combined with oxygen. Non-metals are generally dull, brittle, poor conductors, and form acidic oxides. Rusting requires both air and water, and can be prevented through various methods. Both metals and non-metals are essential in everyday life, metals for their versatile properties in technology and construction, non-metals for life processes and health applications. Understanding these material properties helps us choose the right materials for specific purposes and appreciate how both contribute to our world.